Before attempting this setup program, the operator should be knowledgeable about all material covered in the Davenport Operators Training Program. As a Davenport operator, you have become aware of certain elements of the job layout. In this segment of Davenport Setup Training, we will take a comprehensive look at all elements of the layout and their function in the setup procedure. The layout we will examine is one of the standard formats supplied by Davenport Machine. This format became standard in 1991. There are slight variations to the previous format. These will be explained later in this presentation. Specific layouts are identified numerically in the title block, which is located in the lower right-hand corner. Tools supplied by Davenport for each specific job will be marked with this number followed by a dash number. Directly above the title block are the dimensions of the piece part that is being produced. This drawing contains the tolerance limits required in the production process. The columns found at the bottom of the layout contain information pertinent to machine cycle time, spindle speed, rate of production, and job material. In the first column, the material to be machined is specified along with the required size and shape. This is followed by the model of machine designated as regular, oversize, or chucker. Each of these carries the added designation of extended bed, which provides an additional 2 inches of linear tooling area. Machine cycle will be identified by either 45, 60, or 75. This indicates the maximum number of cycles the machine can make in 1 minute and is generally most pertinent to the index time. For example, a 45 cycle machine index is 7/10 of a second, 60 cycle is 5/10, and 75 cycle is 4/10. Machine cycle is further explained in Tape 4 of this program. If the production process requires the use of the threading clutch, the gear set will be identified numerically by the number of teeth on the driver, followed by the driven gear. This will be followed by the threading method to be used. Further information on available threading methods is found in the instruction book. Moving to the right, we see the cycle time for production listed as seconds per piece. This is the total production time, including index time. The feed gear arrangement used to arrive at the cycle time is listed with the required idler. This arrangement will be discussed further in tape number 6. The gross production per hour does not reflect overall machine efficiency and therefore is basically a reference number. The column listed as revs per 50 hundredths lists the number of work spindle revolutions during the working cycle, or from 0 to 50 cam hundredths. Spindle speed is listed in revolutions per minute. Spindle gears used to achieve the desired spindle speed are listed numerically as the tooth number of the drive gear, followed by the driven gear. Spindle change gears will be discussed further in tape number 5. The surface feet per minute is a factor of the stock OD, and the surface footage is designated in feet per minute. Spindle revolutions during 1 cam hundredth during the work cycle is listed as revs per hundredth. Machining operations are illustrated by individual stations, starting with the first position and progressing downward sequentially to the 5th position, followed by any backworking operation that may apply. To the direct right of each machining illustration are the operations listings for both cross-working and end-working tools. End-working operations are contained in the top block and side-working in the bottom. Required tool holders, spindles, and idler arrangements will be identified either in this block or directly above or below it. It should be noted that in the 5th position, the cross-working and end-working operations are reversed. That is, the cross-working operations are listed in the top box and the end working in the bottom. Moving progressively to the right of the operations column, we see the cams used, listed numerically. Cams used for each operation are stamped with their respective number. The feet of tool is then listed for each operation. This does not necessarily represent the rise on the cam, as that could be affected by block location, but the resultant feed of the tool. When using double or triple rise cams, each feed will be listed. The feed per rev column is the actual distance in inches the tool will move for one revolution of the work spindle. Effective revs are the number of work spindle revolutions required to achieve the desired feed at the required feed per rev. For example, feet of tool divided by feed per rev equals effective revolutions. Block location for each cam lever is then noted. It is very important that block location for each cam lever be in the proper position. This will be explained in Tape 2. Layouts supplied from Davenport starting in 1991 will include a column entitled Cam Starts At. This is the working cam hundredth the tool contacts the material. This number is used in conjunction with a timing system that is mounted on the chuck and feed cam. As this is a new feature on Davenport automatics, we have included a retrofit package with this training program. To the far right of the layout is the tools required list. Here all tooling and attachments for each job are listed.